All right, thank you very much for the introduction. And we'll give a check on this. Okay. The cattle industry is a major component of Tennessee agriculture. And our pastures and hayfields support our beef cattle industry. In 2007, we had 2.5 million acres of permanent pasture and rangeland. 2010, nearly 2 million acres of hay harvested, and that had a production value of over $300 million. Tall fescue is the backbone of our forage base. In the United States, it composes 35 million acres. In Tennessee alone, it's over 85% of the pastures. The cultivar Kentucky 31 was released in 1943, and ever since then it's become known as being dependable, adaptable, and tolerant of grazing and drought. And it currently supports over 8.5 million beef cows and 700,000 horses in the U.S. Here we see a tall fescue suitability map. This area right here is an area of primary use, and we see Tennessee is right in the middle. Coincidentally, Tennessee also lies in the transition zone for warm season and cool season grasses, and this makes tall fescue very appropriate for our climate. It was soon noticed that tall fescue causes a syndrome, fescue toxicosis. It results in increased body temperature, nervousness, rough hair coats, and this is most pronounced during the summer, known as the summer slump. Also, the fescue is declining in growth. But the animals spend more time in the shade, more time in the water, and that means less time grazing and results in reduced average daily gain. The poor performance was attributed to a fescue endophyte, Neotyphodium caeniphilum. It grows in the intercellular spaces of the plant and imparts certain benefits such as drought tolerance and insect deterrence, but it also produces ergot alkaloids that are toxic to livestock. And these concentrations are highest in the seeds and leaf sheaths. Here we see a couple photos of the endophyte and a tall fescue tiller and in the seed. So naturally, the next step was to develop strategies to mitigate these harmful effects. One of these strategies is to plant legumes to dilute the amount of tall fescue and therefore the ergot alkaloids that are present in the consumed forage. Another strategy is feeding hay, because as hay cures, the concentration of alkaloids decrease over time. Another strategy is clipping for mechanical removal of the seed heads before they're mature. And finally, a recent strategy is seed head suppression with herbicides. Chemical seed head suppression began to reduce mowing needs in turf and roadsides with several herbicides. It was then discovered that mefluidide-treated pastures resulted in improved ADG of cattle. And it's also been shown that clethodim reduces seed head density of tall fescue and also reduces total ergot alkaloid concentrations. Metsulfuron is the focus of my study, and it is a sulfonylurea herbicide with a mode of action of an acetolactate synthase inhibitor. It is more commonly used on Bermuda grass and established orchard grass due to their higher tolerance. Metsulfuron decreased fescue seed head density and increased crude protein in tall fescue, but also injures tall fescue. Aminopyrrolid plus metsulfuron has been shown to decrease reproductive tiller density, increase average daily gain, but also it reduces forage mass. Aminocyclopyrrochlor, I'll refer to it after as MAT28, is a new synthetic auxin developed by DuPont. It's a broadleaf herbicide. It will be combined with metsulfuron under the trade name Rejuvra, and registration is expected later this year. The objective of my study was to determine the influence of metsulfuron alone or in combination of other herbicides on seed head suppression and injury in tall fescue, yield and forage quality, and total ergot alkaloid concentration. For my methods, we had a randomized complete block design with 4 replications, 2 locations in East Tennessee, in Alcoa and Crossville, each with 90% infected tall fescue. We had 2 harvests, 1 in spring, 1 in summer, and 8 treatments, including an untreated, a clip at the early boot stage to mechanically remove the seed heads, and 6 herbicides applied in March. We have 2 rates of Rejuvra here at the 0.6x and X rate. This X rate is the anticipated use rate of Rejuvra. as well as metsulfuron alone at the 0.6x and X rate, imidapyrilid plus metsulfuron at the X rate of metsulfuron. This is also known as chaparral. And then herbicide treatment not containing metsulfuron with MAT28 plus 2,4-D. For data collection, we have monthly visual ratings of discoloration and stunting. Seed head density was measured at harvest, and as well as yield measurements. Forage quality analyses determined by NIR, and alkaloid concentrations determined by ELISA for both locations at the May harvest in 2012. Data were then subjected to ANOVA, means separated using Fisher's LSD, and location and harvest or harvest were combined when there was no interaction with treatment. This is a shot of our location in Alcoa and then in Crossville. Moving into data, the first column shows the treatment, second column shows the rate, and this is 2012 combined over both locations. Discoloration and stunning at 4 weeks. We see around 30% stunning at all treatments containing the high rate of metsulfuron, as well as over 50% stunning for all treatments containing metsulfuron. A couple photos, untreated here on the left, Alcoa 4 weeks after treatment. Nice healthy green fescue, MAT28 plus metsulfuron, stunting and yellowing of tall fescue, MAT28 plus 2,4-D, no metsulfuron, again very healthy fescue similar to untreated. The chaparral treatment, again stunning of fescue and yellowing as well. At the 2012 May harvest, 6 weeks after treatment, we see a reduction in seed head density in all treatments containing metsulfuron, as well as the clipping treatment from the untreated control. The MAT28 plus 2,4-D actually had the highest level of seed head density. The stem to leaf ratio was higher in MAT28 plus 2,4-D in the untreated treatment. And the May yield in all treatments containing metsulfuron, there was a significant reduction in yield from the untreated. 2012, at 8 weeks after treatment, discoloration and stunning, less injury than was noted at 4 weeks after treatment, around 20% discoloration in some of the higher rates containing metsulfuron, around 30% stunning. However, in the July yield, there were no significant differences. 8 weeks after treatment in Alcoa, very healthy fescue. Some signs of injury, a little bit of yellowing, but again, not as pronounced in the MAT28 plus metsulfuron treatment. Similar story for chaparral, still some signs of injury, although not as apparent. Forage quality measurements in 2012, crude protein, acid detergent fiber, and total digestible nutrients. Metsulfuron combined with other herbicides or applied alone reduced ADF, increased crude protein, and increased TDN in comparison to the untreated. This is alkaloid concentration in parts per billion. The y-axis, parts per billion total ergot alkaloids. The x-axis, all of my 8 treatments. This is again for both locations in 2012 May harvest. Untreated, around 1,700 parts per billion. And all treatments containing metsulfuron, around a 30% decrease in total ergot alkaloid concentrations. Some data from last year, 2013. Similar story, around 50% stunning at 4 weeks after treatment, and some of the treatments containing the high rate of metsulfuron. 7 weeks after treatment, starting to recover, not as much injury again. However, we saw a location difference in 2013 between Alcoa and Crossville. And Alcoa, with not as much reduction in seed head density, I attribute that to the main thing would be rainfall, very wet year. Fescue loved it. Of course, we didn't like it because it means we couldn't get in the field to harvest. That delayed our harvest. That contributed to some of the differences. But in Crossville, very easy to harvest, and we see very good differences in our data. The MAT28 plus 2,4-D had the highest seed head density. All treatments containing metsulfuron, significant reduction. 2013 May yield, again, all treatments containing metsulfuron reduced the May yield significantly. However, the second harvest in August, no significant differences. In conclusion, metsulfuron applied alone or in combination with other herbicides reduces seed head density in tall fescue. However, that results in a yield reduction in May. But this also improves forage quality as seen by the increase in crude protein, decrease in ADF, and increase in total digestible nutrients. These treatments containing metsulfuron have the potential to reduce the severity of fescue toxicosis as seen by the decrease in total ergot alkaloids. And these results are similar to the ones shown by Aiken and others in 2012. Some additional research, some follow-up ratings, yield measurements, and tiller counts for this study, forage quality and alkaloid analyses for the 2013 harvests, and then application timing studies to see the different rates of injury on tall fescue at different times of year, and also can we balance, still have seed head reduction, but not as much of a yield impact. Some of my references. Thank you very much, and I'll entertain any questions.
Any questions for Any grazing restrictions, hay restrictions on metsulfuron?
The question was, are there any grazing or haying restrictions with metsulfuron? I don't have the manual with me for metsulfuron. I do not believe there's any grazing or haying restrictions. Now, there are differences between lactating dairy cattle, non-lactating dairy cattle, and beef cattle. I can't remember those off the top of my head, but for beef cattle, I believe there are no restrictions. Yes, sir.
So Tennessee and where I'm at in Georgia is kind of the southern range of where tall fescue is really well adapted. It's kind of getting pressure from years of drought and other kinds of bad weather. Is this something that you think you would recommend to your producers to do in your region to do this, or do you think the risk of stand loss would be too great?
The question was, would I recommend this to producers in my region given the impact on the stand? Well, first let me say about the Rejuva is not yet registered for pasture, so I can't recommend that. However, Chaparral is, and there have been a lot of instances where the company representatives are actively pursuing this. I've heard of several studies that people are going and comparing the ADG of cattle grazing non-treated versus chaparral treated. I've heard differing stories. If this were to be put into place, it could improve the forage quality, but it would require a lot of assistance from company representatives as well as extension specialists. It would be very a lot of hand holding, I should say, because it would impact the stand if used incorrectly. Yes, sir.
What was your target for alcohol? Is there a target to try to reach for toxicosis?
The question was, is there a target for alkaloids? I can't say that with a lot of certainty because it varies from year to year, as seen in the and time of year, as seen from Krista's presentation. There's a lot of factors that impact total ergot alkaloid concentrations as well as ergovaline. But in my opinion, a 30% reduction in any year would benefit. The ergovaline is the highest, is the one in the most concentration of all the ergot alkaloids. I can't say if there's a target because it varies so much, depends on so many factors.
I mean, just 1,000 parts per billion is a lot of alcohol. I mean, it's pretty toxic.
Right, and that any reduction, I mean, to compare it to what else are they going to graze, I think would be the question. If you can get it down that far, that great, but what's the impact on the stand would be the other side of the coin. Yes. Question was, did I use surfactant? Yes, I used a 1/4% non-ionic surfactant with all the herbicide treatments.
Trevor, did y'all look at, you had some impact in your final summary on quality of the forage, availability of the forage, and how it translated to ultimately pounds of beef per acre?
Right.
I was wondering from an economic standpoint, I don't know what these applications would cost, but there's obviously a cost associated with the spraying. I was wondering how that, did you look at all at what it would take in terms of increased productivity to offset that?
The question was what the benefits of spraying plus the cost added, how would that offset any yield losses? Or my answer was it would take a very sophisticated economics equation to do that, and my opinion would be to account for everything from the herbicide treatments, not only improvements in forage quality, maybe a factor like crude protein per acre, crude protein per unit area, forage quality like that, as well as other benefits of herbicide treatment like weed control. That's another topic that I didn't even cover, and that would be another benefit of herbicide application. So it would have to be a very complicated equation, but I have seen some in the research that looks at crude protein per acre as well as taking into a lot of factors, but I would have to have help from an economist for that.